Pak Kaprodi, selamat siang. Nah, berapa orang? Masih banyak orang, Mas. Selamat siang, Pak Kaprodi. Bagus ini dia.
Tes, gimana? Benar nggak? Halo, Franz, kedengaran nggak, Franz?
Kedengaran, Pak.
Oke. Uh, I'm sorry for the late, Mr. Suppasri. Correct me if I'm wrong with your pronounce of your name. But okay, good afternoon, everyone. Today we have a lecture about uh, about Japan lesson learned on tsunami for enhancing coastal community resilience in Indonesia with key speaker Dr. Annawat Suppasri. I'm sorry if I pronounce your name is wrong, but I try my best. Mr. I will introduce about the speaker. Dr. Annawat Suppasri is an associate professor from International Research Institute of Disaster Science, Tohoku University, with the educational background, PhD in Tsunami Engineering, Tohoku University, Master of Engineering in Water Engineering and Management, Asian Institute of Technology, and Bachelor in Civil Engineering, Chulalongkorn University. His expertise in tsunami numerical modeling, tsunami generation mechanism, and tsunami damage field survey, tsunami vulnerability, and tsunami hazard and risk evaluation, and disaster prevention education. So today we will learn a lot of tsunami with Mr. Suppasri. He will introduce and he will teach us about everything he knows about this tsunami. So thank you for your time. I think we can start now.
Okay, thank you so much. Can you hear my voice? Okay. If my voice is clear, it's okay. Maybe I will start sharing my screen. Uh, is is this okay, my screen? So I hope that it is okay. So thank you for your introduction. I'm very happy to be here, and I'm sorry that today we couldn't make it face to face because of some university regulation. Um, as introduced, my name is Annawat Suppasri from Tokyo University in Japan, and the just a moment, please. My university is located here. If you remember, we had 2011 tsunami in Japan more than 10 years ago. That is where we live, and I experienced the tsunami. I originally from Thailand, so I experienced also 2004 tsunami in Aceh that also hit Thailand as well. So that's my um, inspiration to learn to study about tsunami more. And then I experienced another tsunami in Japan. So that's about my background. So I start my tsunami research since then, since my experience 2004. So today my talk will be about maybe 1 hours about tsunami in Japan, how we mitigate the tsunami. Of course, we had a big tsunami in 2011, but still not enough for preparation. So after that, we did some more um, of what I would like to. I have been doing some research in Indonesia as well, like in Palu or in Krakatau in 2018. So this kind of, which is not non-seismic tsunami event. So I would like to show you also how we learn more about recent tsunami. I try I try to speak a little bit slow, but for that I might have to skip some slide that to fit the time. So again as you I'm sure that you already know that tsunami is generated by earthquake for maybe let's say 80% of the tsunami. And for example the phenomena or what you have learned from Aceh that you might or other place you might have heard or learned that um, before the before big tsunami arrive, maybe you'll see the water retreat back to the sea. So this animation, this photo figure show the simulation of sea floor in the brown, and the blue is the sea surface. So you can see after earthquake, some part of the sea floor goes down, and that's why the water on the top might have to also goes down, and then it generates tsunami. So like so that means if you are in this side, the right side of this figure, so you will see that phenomena that the water retreat. But if you stand on the other side of this earthquake, you will not see such water recede. You will see the big wall coming suddenly. So this is kind of information that some people might only, okay, let's see, let's wait for the retreat wave. But actually, it's not 100% true. It's just 50%, depends on where you.
Foto sekali kita di depan ya, ada BPBD.
Oh ya,
oh ya. Biar ada bukti juga.
Maybe I can just continue. Okay.
Di foto bareng di
Okay, I think you can Someone mute me. It's okay. I repeat again. So you can see that this is 2004 tsunami. Why? This is a time. Still, why many people die. Of course, in Aceh, it's difficult because the time is quite fast, but still, like 8,000 people died in Thailand or 30,000 people died in Sri Lanka. So you can see, even in Thailand, we have more than 1 hour to evacuate, or same in Sri Lanka, 1.5 hours. But because we had no warning system, we have no knowledge about tsunami. So even we have time, but people couldn't evacuate. And you can see that tsunami from both sides to Thailand and to Sri Lanka arrived about at the same time. You can see after about 1.5 hours. Today we don't have time and we do it online, so it's quite hard to do some like interaction. But so you might wonder, the distance from here to Thailand is more shorter than from here to Sri Lanka. But actually, tsunami travel faster, can go faster in the deep sea. So this part, the sea is much more deeper. So that's why tsunami could go very fast and arrive at the same time to Thailand as well. So that's another things that you can learn about physics of tsunami. And this video shows the how tsunami in Japan in 2011. So you can see this is time in hour. Similarly, tsunami has no border. So one is generated, it's go through many places in the world. It's arrived Hawaii around after 7 hours, and it reached America and other countries in the South America as well after one day. But this time we had tsunami warning system throughout all the world, or we have news, we have other SNS tools that we can use these two medias to warn people. So almost no people died outside Thailand, in Japan, in case of this tsunami. So that's you can see how we improve or reduce the disaster loss by the technology. This is similar, so I will skip. So just to show that tsunami also, like in 1960 and 2010, also we had big tsunami from Chile that go through Pacific Ocean and arrive Japan after one day. So because tsunami is we call like low frequency, so tsunami big one, it might happen like once in 1,000 years or 500 years, like that. So it's not so frequent like compared to other disaster like flood or typhoon or some small earthquake. So it's very challenging how we keep awareness of people. So these maps shows for example, if we take the tsunami map, the historical tsunami, and we do some simulation to show height of tsunami from 2 or above. Very big tsunami during our own experience. So for example, from 1970, we have about 40 events, but the big ones, there are only 2004 in here in Indonesia and 2011 in Japan. But if we looking back more longer, like 400 years ago, or it's not our direct experience, but his written document or storytelling from our grandfather, grandmother, like that, you can see that actually we had many tsunami as well, not in all around the world, not only in Indonesia or in Japan, but other countries like along the west coast of America or in the South America or even in the Atlantic Ocean. This one is 1755 in Lisbon. So you can see that big tsunami could be actually everywhere in the world, but just it didn't happen during your living experience. So that is very tricky how challenging how we can convey our awareness or story of experience of tsunami. Back into Japan, how we experience and how we develop our tsunami disaster mitigation based on our experience. So I would like to start from what had happened in Japan so far. So we had long history of tsunami from this year 800 more than 1,000 years ago, 869. It's not in this list. But anyway, so you can see tsunami in 1611, 1896, 1933, like this. For the big one around here, this is where I lived. And another set of moderate tsunami earthquake since 1793. Every, let's say, 40 years, we have moderate earthquake and small tsunami. So before 2011 tsunami, we were prepared for this earthquake and tsunami, which is quite small. Tsunami could be like few meters. But what happened in 2011, as you can see in this graph, tsunami like 10 meters or more than 20 meters in many places along the north of the Japan. So what we prepare and what had happened was totally different because we only have real good record of this one. So that's another case. And of course, we have learned about, we know about the tsunami in more than 1,000 years ago, but we have no idea. For example, we know that from the sediment study, we found that the sands transported by tsunami could reach along this red line. So we do some simulation to prove that how far tsunami could go inland, but we have no idea if the tsunami source can be much bigger or when the sand already sink down, how far the water can go further inland. So this kind of limit information. So this is example. So for example, we in one area when we dig down the right paddy field, you can see like sand layers here, sand from tsunami 1,000 years ago, 400 years ago, and 2011 tsunami. So we use this kind of geological survey. We use also historical record or document proof that we had tsunami in this village or simulation, engineering simulation to work together for this disaster. Similarly, this one in 1700 in the west coast of US, that there was a big earthquake that generated tsunami, but at that time no people lived there. So, but there was a records in Japan. So having that, so we do some reverse simulation that okay, tsunami from the US should also arrive Japan, something like that. So again, we work with other people from different perspectives. In this case, engineering, science, and history to understand the historical tsunami. So in Japan, like where I live, we have several tsunami, but it has different types as well. So this one. So normally you might think that okay, big earthquake might create big tsunami, but it's not always true. Sometimes it's different. Like this one in 1896, we call a tsunami earthquake type. So that means the earthquake itself is very small, but then it takes long time. So and it could produce very large tsunami, like 38 maximum to 38 meter. So people, that's why at that time why many people die, because they didn't evacuate, because the shake was small. Or in 1960, this time tsunami, as I show you in the animation, tsunami generated from Chile, so it takes 1 day to Japan. So there was no shake of the earthquake. So people couldn't evacuate, and many people also died in Japan like that. So yeah, these kind of some information that of course in the past, people in the past, they have no knowledge about earthquake and tsunami. But yeah, so this is how we learn. And sometimes, like in Palu or other place in Indonesia as well, if the earthquake is really close to the shore, tsunami could arrive within few minutes. So that means even the warning system might not very helpful. So you need a natural warning, which is the ground shaking. If you feel the shake, you should evacuate as soon as possible. You cannot wait for the alarm for a local tsunami like this. But anyway, for what we can do, so in Japan, we start our tsunami warning system since like more than half of decades. But to do that, we do some simulation. We assume that, okay, where are possible earthquake source, so we put, and then we do many simulations. So from the simulation result, we store in the database, so we know, okay, so if the earthquake, then we give the warning 3 minutes after the earthquake. But still, as I mentioned, sometimes the earthquake is very close to the shore, so even this kind of system cannot release in time. Or if it generate landslide, local landslide, and then tsunami, still this kind of system cannot help so much. So in the case of 2011, as I mentioned, we didn't expect such magnitude 9 tsunami. At the beginning, we a problem, but after a while, we observe the large tsunami in the sea, so we upgrade the tsunami warning level to 6 meter or to 10 meter. But the problem is that is some area, they already lost their power, no electricity, so the update information could not reach the local people. So again, they should, if you, they should rely on their own. So if they, from the first warning, if they evacuate that's faster. So for the government perspective, so after 2011, they changed the warning criteria from 8 levels to 5 levels to be more simple, so that people can understand more about the categories of the tsunami. And also they have deployed many sensors along the Japan Trench. This is like undersea, including the sea bottom sensors, so it can detect both earthquake and tsunami at the same time, or even tsunami from non-earthquake source, like 2022 tsunami from Tonga. These observational system can help detecting the tsunami. I think I will skip some slide because of the time. And so in Japan, how we protect the community from the tsunami. So I would like to show some structural measure. Of course, it's not maybe not so applicable to Indonesia, but this is what we are doing so far. So we have what we call breakwater, which is the, I don't have the photo, but so it's like, maybe you can see these two like a wall in the sea. So the sea here, the sea depth is about 60 meter. So this is a very big structure, superstructure, like 20 stories building in the sea, and it's about 6 meter or 7 meter above the mean sea level. So it's very big structures they built in the bay entrance, because in 1960 big tsunami from Chile hit largely hit this city. So that's why they built this kind of breakwater, hoping that it can help to really minimize the tsunami power. And some area, like when we have river mouth, so the tsunami can go through inland through the river as well. So they built the flood wall here, like a wall to protect the water tsunami to go to the inland through the river. Or this is again photo before 2011 in Taro town, where they built a seawall that to protect the town. And then after a while, people start to build buildings outside of the wall. So they build another wall again. So, and we have in Japan, we don't have mangrove like in Indonesia, but we have pine tree. So we build this one like pine forest here. So we sometimes this can help protect tsunami for small tsunami, and also we ask people to live in the high ground for some low area like this. So but these things has been more this breakwater, this seawall, and the pine forest has been totally damaged, destroyed by the 2011 tsunami. Because, like for example, for the trees, it can only withstand tsunami up to a few meters, 2 or 3 meters. So, but this in 2011 tsunami was like more than 10 meters. So that's very difficult. It's too big for green belt for such a big tsunami. So we need to combine both concrete and the eco-friendly green countermeasure. But this is just to show you what we have in Japan. So how we develop the countermeasure, again, for example, I use the same example. The tsunami in 2000 in 1000 in this period is too old. At the time, it is difficult to ask people. Of course, we ask people to live to the high ground, but they are mostly fishermen, so it's difficult for them to live far from the sea. So after they moved to high ground, after a while, they came back to the sea, and then they were hit by the tsunami again. So since then, we thought that we should build some seawall, some structures. So yeah, so some area they start to build some wall like this. And this wall help to protect tsunami from Chile, even there was no tsunami warning, but because they had walls, some walls, so that the wall helped to protect some village from the tsunami from Chile. So that's a good thing, but on the other side, it makes overconfidence. So they thought that having concrete structure can solve everything. So, but that is not the good idea, because like other areas, tsunami might come very fast and might bigger than the wall, or similar to 2011. So we should combine both structural and non-structural countermeasure, so that to make sure that we can optimize the tsunami reduction. So again, so we learn a lot when that we, for example, in some area, the tsunami hazard map can be different to what we expect. Of course, we do our best to reproduce a good one, but like in this case in Sendai, where I live, the predict one is in the blue, but the real one is in the red. So it's in some areas largely different. So after this 2011, we try to add more worst case and think about also more on education and raising awareness of people not to stick in the too much into the hazard map. Just we have to also rely on our experience or decision making at that time. And this is too many text, sorry, but I would like to say that from the survey, we also know that even in Japan, not many people, only half of them, they do evacuate, they run to the high ground. And the traffic jam was very serious. I can see in Ambon that there are many traffics also, but in Japan also during the emergency, also people try to use car and cause the traffic, and of course there's no electricity, so it causes a large traffic jam. And so, but again, in Japan, we still built some certain level of seawall or concrete structures. So how to decide this? We make into two types: tsunami level 1 and level 2. Level 1 mean very high frequency of the tsunami. So every let's say 50 or 100 years, 200 years, also to moderate tsunami, we build the tsunami wall as part of this one. But for a very big tsunami like the one in Aceh or in 2011, we give up. We let the water tsunami overtop the wall, but we make sure that we have enough time, and we have for the evacuation, or we have secure a good evacuation routes, etc. And as a role of university, what we help local government to rebuild the city. For example, in Sendai, we already have the highway here. It's like elevated road here, and we have seawall, we have pine trees, but still tsunami could go very far like this. So what we help local government, so we got an idea that this highway helped to protect tsunami. So we built another, that's an idea to build another road here. But again, the problem is how high is good to build. So we built, we make some simulation, like, okay, try different height of the road, maybe 1, 2, 3, 4, 5, like that, and we come to the conclusion that 6 meter is a good height in terms of tsunami reduction and also the economic perspective. So this is how simulation engineering, or how we contribute. So we make decision. We help the local government providing some information for them to make decision. In area where I live, there are two types of areas as well. The land, but this is very flat. So in that case, like what I showed in the last slide, we have we have nowhere to evacuate. So we need what we call multi-layer. We need many layers to protect the tsunami.
Selamat siang, gadis.
But then
Ada kegiatan nih?
for the other place, we use the making use of the terrain or topography. This is quite similar to Ambon, I guess, where you can have access to the high ground very easy. So in Japan also, we didn't after tsunami again. So after tsunami, the land is already flat. So our house or things has been destroyed. So we say, okay, this area is not allowed to live. So we cut some part of mountain to increase the land elevation in the lowland, and we ask them to live in the high ground. So this might be difficult to apply to Indonesia, but in other hand, if you have access to the high ground, so as long as you could make sure that you have evacuation route is clean and clear, it can be easily seen at night like that. So that should be enough for an urgent response. This is similar. This is just to show that people in the past actually this is a historical map here, and I overlay with 2011 tsunami map, so it shows that actually people in the past 400 years ago they already lived somewhere far, but then after a while they start to forget about the historical experience and live in many places along the sea, and then they got tsunami again. So again, it is very challenging how we can transfer our experience or knowledge from the past to the next or future generation. And this just to show you some damage of 2011 photos. And you see this is engineering. For engineering perspective, you can see that the seawall in the seaside, it looks okay, but once the water overtop the seawall, the flow speed is very high, so it generates the strong erosion scale on the backside or the land side. So it fell like this. So as I mentioned somewhere here, so like this. So we have to build much stronger structure on the back side. And for example here, this is pine tree in Japan. So you can see, so if the tsunami was very high, too high, so like 5, 6, 7, 8 meters, the tree cannot withstand against tsunami, so it will be like this. So we have to choose as well what is the expected site of tsunami. If we know that it might be higher than the capacity of the tree, in that case we have to combine with some other measures. Also, you can see, even though these 3 buildings were hit by the same tsunami 4 meter, but you can see that reinforced concrete building is much stronger than other wooden house, or even reinforced concrete building, but like this area is reclaimed land. It used to be a sea, so they built a new land from the sea. So after earthquake, the soil was not so strong. So liquefaction happened, and most building here they have small openings. So you can see that the structure itself looks okay, but it's turned around or overturned like this. So this is kind of a new what we learned from the failure from this 2011 tsunami as well. We need to build strong foundation of the building. And for the recovery, again, we need to make sure that everyone is happy. So I choose one example here in the city called Kesenuma, where they used to have a very nice white sandy beach and emerald green sea, like many places in Indonesia. But after earthquake and tsunami, so the government originally they proposed to build much bigger wall to protect the town, the village. But bigger wall means you have to build bigger foundation, much bigger, and this part will be in the sandy beach. Of course, and this is like very big wall, it obstruct the view, so they cannot see the sea. like this. So when the government propose this to local people, of course, they don't want this kind of plan. So they rethink again, the government, how to solve this to make sure that people will have the sand beach and also the side, the eyesight will not be blocked. So what the final plan is like this. So they say, okay, we keep the width of the sand beach as it used to have before tsunami. We call setback. And then to solve the problem of the site, the eyesight, so they increase the land, you elevate the land behind the road like this. So it's like you drive on the seawall like this. So by doing this, you can see this beautiful sea from the elevated ground. Of course, we use budget for that, but this can help um, solve everything. We can solve the landscape problem, we can solve the safety problem, and we can also solve the environmental issue as well. So this is kind of a good example that we made it in Japan. And also for the point that how we can transfer our knowledge to the future generation. So we keep, well, this is like Indonesia or in Thailand, we have like boats or other damaged building, and we keep as a memorial. So in Japan also we're trying to keep these kind of structures, but many of them it was difficult. Like here, people don't want to see these kind of things anymore. It recall their bad memories, so we have to demolish it. It's no longer. So this kind of thing can be used to recall the experience, but it can be a negative point as well. So that's a very difficult issue and should be discussed between the local people and the government together to decide whether we will keep or not. So there's no correct or wrong, but yeah, it also takes time to make decision. And before I end my presentation, I would like to spend maybe 10 or 15 minutes more just to tell you a little bit more the current trend of research or topics of tsunami, what we are doing so far. So in general, if we talk about risk, disaster risk, so these are the components of the disaster, which is the hazard. It can be flood or tsunami, earthquake, whatever. This is like that. And exposure, I mean our community, buildings, etc. And vulnerability, it means how, for example, tsunami depth, flood depths, and how many percent building can be damaged. So of course, for example, reinforced concrete building has less vulnerability than the wooden house, for example. So these are the risk components. So another example is, for example, if we have like 10 meters of tsunami, but happened in the place where no one lived there. So we will not say disaster because nothing, it just hazard like that. So this is the component, a basic component that you should understand first. And for the hazard itself, what we are doing right now and the current trend that we concern. So of course we concern about the impact from global warming and what global warming can influence tsunami. So it is the sea level rise. So we also start doing research on sea level rise and how it influence tsunami as well. So we do some simulation just to show, for example, here the blue areas only tsunami, but then red and yellow shows tsunami plus sea level rise. It can go further, or in some area, even sea level rise itself only 70 centimeters, but for the mountain or slope area, it can be double size of the sea level rise. So this kind of thing that we we should also take into account when we do design or the tsunami in the future. Or this one show another perspective of sea level rise. For example, the black lines show, okay, in this area, if we expected tsunami of 1 meter or more, the return period, the frequency of the tsunami is about 960 years. But if we have sea level rise of 50 centimeters or 1 meter, the frequency of the that event will be reduced to 800 years or 450 years, like this. So that means for the same tsunami, it can happen more sooner than before because of the sea level rise. And recently, there are many types of tsunami that is not from earthquake. So, for example, in 2018, for Palu as well, even though the earthquake happened, but it was lateral earthquake, and it generate many tsunami by landslide like this. So there was no time to evacuate. So I guess Palu and Ambon, the topography looks very similar, the shape and the land. So we have lowland along this. So if we have earthquake, but then submarine landslide can also happen like this. So that is, in this case, tsunami could arrive within very few minutes. So yeah, so we need to evacuate, to run as soon as possible. We cannot wait for the warning. This is another example of non-earthquake, non-seismic tsunami when we have the eruption of Krakatau in 2018. Not sure you remember. Again, I will go. The mountain, the volcano, this part collapse and generate tsunami like this. So this time even much difficult because no earthquake. So the current earthquake tsunami warning system can only predict or help with the earthquake source. But this one, no earthquake, no ground shaking. So tsunami silently approach to land like this. So that's very difficult situation. And 2022, also we had tsunami from the volcanic eruption in Tonga, and that's because of the change of air pressure. Here change of air pressure travel to around the world, also generate tsunami and attack Japan, and it damaged also fishing boats and also fishing facilities. So this is another very not so frequent, but also happen and generate some damage. Some similar event of this one happened in Indonesia in Krakatau in 1883 as well. I think I will go a little bit quick. So we were also I would like to also tell you about this experience as well. If you remember the news, on the New Year Day in Japan, we had a very big earthquake in the area called Noto Peninsula here, which of course we expect that event to be happened, but it happened on the New Year Day. So that's where people go back to the hometown and see their family. That is a very bad timing. So in 2014, 3 years after 2011, we start to revise our tsunami studies in the not the Pacific coast, which is where I live, but in another side because the Sea of Japan. So they revised the possibilities of the earthquake along this area, and they revised the hazard map or estimation of maximum tsunami height for each area. So the earthquake itself is not only earthquake damaged by the earthquake ground shaking, but many landslide, many liquefaction and submarine landslide, generate tsunami, and large uplift. The land increase like this. So there are so many disaster came out after the earthquake. And we can see also that from this data that even in Japan, they built a building quite strong against earthquake, but the buildings in this area are quite weak compared to other area in Japan. So again, still more than 80% of people killed because of the earthquake. But even though tsunami, let me show this one first. You can see that tsunami could hit here very soon, right? Because the source earthquake is here, so tsunami could arrive very soon, within few minutes or 5 minutes like that. But from the data, only two person died because of tsunami. So that means actually people in this area, they did a lot of evacuation. They have a high awareness of tsunami, even so they know that tsunami could arrive that place very soon. So they do evacuation by aiming that tsunami. I mean, they should be able to evacuate to run to the safe place within 5 minutes. So this is what they do in the drill. So that helped very much the person to reduce the percentage of the people died killed by tsunami. But for the other perspective, we also found that many people die because of the coldness. It happened during the winter, so even they could survive under the debris, but then it takes time for the rescue to save the people. So that's why that is another issue. And this is what you might not so familiar, but after earthquake, as I showed in the beginning of my talk, that some area might go up, and because this case, the earthquake epicenter was really close to the land. So, and this one, the port, you can see the Google map before and after the port lift up 4 meters. It's like this. So it's very difficult for the fishing port as well, how they can reuse this fishing port or in the future. And it also generate landslide tsunami as well. We also found from the survey, bathymetric survey, before and after tsunami, that this is a cross section to show that in some area the ground is slowing down or disappear. So we could say estimate that these areas are a submarine landslide, and it generate a very early arrival of the tsunami. And this is another example that one of the famous tourist spot here. We have the CCTV camera, and we can see that before the earthquake, there's many tourists along the beach to see the sea and famous spot. But soon after the earthquake, they already evacuate to somewhere, and no one in this area. So natural warning, and of course the official warning to the speaker or to the mobile phone is very useful as well to save people's life. Again, education or self-evacuate without warning is also very important. So in Japan, right now, actually last month we also had another big earthquake, and let me go this one first. So actually in Japan, we had many earthquakes since the year 684, let's say more than 1,000 years ago, keep occurring in the west of Japan. So actually in 2011 tsunami also, it was happened on March 11, but actually March 9, or 2 days before the real event, we had magnitude 7.3 or smaller earthquake, then followed by the big one, magnitude 9. But at that time, we didn't know that we will have very big earthquake following this earthquake after 2 days. So now even though we have no strong scientific background, but we have the period event like this. So in the future, in this area, the red area, if we have magnitude 7 or more in this area, we will announce the potential for the large earthquake to warn people. Or last month as well, we in August the 8th, we had a big or moderate tsunami earthquake in this area, which is in the area that we expect to have the very big earthquake. So after August 8th earthquake, we it's magnitude more than 7, so they released the earthquake warning for 1 week, but it's actually just before the long holiday in Japan. So it was a very difficult situation for tourism or for other things. So people wanted to go back home to see family or to do vacation, but many cancel of the hotels or some economic damage, which is very difficult to then now they are reconsider how to improve this kind of system. So again, this is the only way that we can also just warn people because we have the period experience of 2011. So this is my last slide, just to again today I talk several things, including countermeasure tsunami characteristic to understand what is the physics of tsunami, and also how we protect tsunami for both structural and non-structural measures. But I told many times that the most important is the awareness of people. And so for this one, actually from 2016, the Japanese government proposed this day, the 5th of November, as a World Tsunami Awareness Day. This is why this day, because in 1854, there was a big earthquake, this one, in this area. So he is the leader of the village, and it was at night where people had a party or enjoying the time. But then the earthquake happened, but he think it's difficult to let his villagers evacuate to high ground. So he put fire on his right shafts like this. Even this is a time for the rice grown up, but this kind of action, so that to make sure that people evacuate to high ground, he saved his villagers' life. So this is like a heroic story. So the government proposed to the UN, and they make this as a World Awareness Day. So I believe that even though Indonesia and other countries during this week, this day, there are more several activities like for tsunami education, awareness, or disaster drill. I'm not sure if we have such activities in Ambon, but yeah, but I'm sure there are several activities in Indonesia as well. So yeah, so that's kind of another way that we wanted to remain or keep the awareness of tsunami to the future generations. So I hope that by listening to my talk today, this information might help you, or if please tell to your family, your parents, your friends that okay, what you have learned today, and I hope that it can save your life or your family in the future, or the way of thinking, how we can fight against disaster can be also applicable to other different types of disaster as well. So I hope that this can be useful for your future. By saying that, I would like to thank for your attention, and I'm not sure if you want to ask some questions. Thank you.
Oke, kedengaran ya? Thank you, Mr. Annawat Suppasri, for the good presentation and very helpful education and lesson for us. So I think I kind of review a little bit for my student. Maybe you can wait for a while
Okay.
because I will talk in Indonesian. So, okay. Uh, Adik-adik mahasiswa, jadi Pak Dr. Annawat Suppasri ini tadi menjelaskan tentang sejarah dari bencana tsunami yang terjadi di seluruh dunia, tapi beliau lebih fokus di kawasan Jepang dan sekitarnya, ya, dari periode beberapa ratus tahun yang lalu sampai yang terkenal itu 2004 di Aceh, 2011 di Jepang, dan beberapa bencana yang terjadi di tahun-tahun tersebut. Jadi tadi beliau menjelaskan sedikit tentang sejarah-sejarahnya, kemudian beliau menjelaskan juga tentang prevention atau pencegahan yang dilakukan oleh pemerintahan Jepang, baik dari secara kebijakan maupun struktural. Ya, jadi tadi ada terkait teknologi brick wall, brick water ya untuk tembok di laut gitu. Terus tentang sensor di dalam laut yang untuk sebagai pencegahan awal, pendeteksi dini ada punya bahaya tsunami atau enggak ya. Jadi kemudian beberapa penjelasan terkait pengaruhnya yang akibat dari tsunami terhadap masyarakat. Jadi dengan ada beberapa sejarah yang terjadi tsunami di Jepang itu kemudian mengarahkan pemerintah di sana dan masyarakat setempat untuk memperbaiki kawasannya, meningkatkan pengetahuan dan teknologinya dalam mengantisipasi musibah tsunami. Ya, jadi itu yang bisa parah sedikit, kurang lebihnya mungkin kalian bisa memahami tadi. Jadi sesaat lagi kita akan masuk ke sesi tanya jawab. Hanya saja sudah ada 2 pertanyaan di sini. Jadi mungkin nanti Pak arahkan untuk beliau mendiskusikan ini dulu. Okay, Mr. Annawat, there is a
Yeah, I can see in the chat.
question.
I just
Maybe
answer. I read
yes.
already.
Okay, thank you very much,
Thank
Mr.
you. So there are 2 chats. So the first one, okay, maybe I don't have doubts. I can just answer. So the question,
Yeah.
so for the first one, so because my answer, of course there are 2 types of earthquake, which is one can be the source can be very far, like from Banda Sea, but we also I also learned from my colleagues that doing tsunami in this area that it can be also a source near inside Ambon, or it can be potential landslide as well. So for my own opinion, I think we need to follow. I mean, for Ambon, we should what we experience from Palu as well, because the topographical setting is quite similar and the types of hazard is also quite similar. So of course we learn that so we raise awareness, and we know that tsunami could arrive very soon. Of course, depends on the source. If from Mandasi you have time, but if the local earthquake near the bay or some money landslide can, like in that case, tsunami could arrive very soon. So do not wait for the warning. Of course, if we hear the warning, that's also good. But if there is no warning, but if you feel the shake, that is the natural warning. So that's kind of trigger that you have to start our evacuation. And how to save time. Okay, we need to prepare our emergency bag, or my own experience of 2011 as well. All the phone network was down, so we should talk with our family member that, okay, if during disaster our parents live working another place, we live in another place, so how can we gather? Where shall we go? 1, 2, 3. We define the place beforehand where to go, like that. So this kind of thing. And the most important thing in Japan, what we think is that of course, even we feel the shake or the warning happen, we evacuate, but nothing happened, no tsunami. But we try to think more positively. So better not to say, oh, we evacuate already, but why no tsunami? But try to think in more positive way. Oh, we are lucky this time, no tsunami, and this is a good time, a good chance for us to do the drill like that. So this is not to be, like pessimistic. So try to be positive and think in a good way, and that can help also to improve. Maybe during that, when you evacuate, you might realize that, okay, what you should do more to improve the situation, etc. So that is what we would like to answer for the first one. Because in Japan also, we also have the word saying like you should go by yourself. To save our life is your responsibility to save your own life. So yeah, so that's the thing we need to, because it's very fast for tsunami. It can be very fast for this area. So the second one about the structural measure, yes. So we have many of them in Japan, but of course we talk with local people that even though we have such structures, but sometimes it can be bigger. So we should not look down, or I'll say not to be too positive to the structures. And so, for example, in some area in Taro town, even though they have the wall, but people they also um, evacuate. Um, So we need to make sure that people understand that, okay, what is the limitation of the wall? Okay, we have how high of the wall? What is the height of the wall? If tsunami overtop, so this can be the area until where can be flood, for example. So this kind of understanding, and also communicate the the community. In Japan, we also check beforehand. Okay, which house has this disabled person. So in the case of disaster, we will go and pick up that person and evacuate together, because this person have no they cannot run by themselves, for example. So this kind of thing, very small thing, but little by little, and then when we connect together, we can make a good effort or good result. Okay, maybe one or two more question before I have to move. Or if
Oke.
difficult to speak, you can type in the chat as you say in the moderator.
Oke. Thank you Mr. Ahmad. Jadi tadi itu penjelasannya terkait, ya intinya kalau ada peringatan ya sudah, kita secepatnya mengantisipasi terkait adanya tsunami. Jadi kalau misalnya disuruh lari, ya sudah lari aja, nggak usah tunggu-tunggu lah atau gimana. Jadi jangan main-main dengan peringatan dini oleh pemerintah maupun gejala alam yang sudah kita alami. Itu yang pertama. Yang kedua, proses evakuasi itu harus dilakukan secepatnya, sehingga untuk mengantisipasi permasalahan atau korban yang jauh lebih buruk. Jadi memang permasalahan tsunami ini kan kita tidak bisa anggap sepele, sehingga kita harus tetap waspada. Meskipun kita sudah lari pun, tapi kalau tidak ada tsunami nggak masalah juga. Yang penting kita sudah membiasakan diri untuk mencegah atau berpikiran positif bahwa setiap ada peringatan kita harus mengantisipasi dengan cepat dan tepat. Jadi itu. Jadi jangan menganggap remeh terkait hal bencana alam seperti ini. Jadi untuk semua hal-hal yang harus diperhatikan itu memang tidak bisa ditanggapi dengan sepele ya. Jadi memang apapun yang dilakukan oleh pemerintah, baik peringatan, terus pada saat terjadi tsunami maupun penanggulangannya, itu harus diperhatikan dengan baik oleh seluruh aspek masyarakatnya. Iya. Mungkin ada lagi yang mau bertanya? Silakan. Satu orang silakan.
Pak boleh bertanya, tapi
Oke.
mungkin saya berbicara, mungkin Pak bisa bantu untuk translate.
Okay. Mister, there is a one more
Okay.
person want to ask, but
Yeah,
he will
that's
talk
one.
in Indonesian, then I will
Translate.
translate
Yeah,
in
sure.
English.
Yeah, the last one. Yeah.
Oke, silakan. Siapa tadi?
Okay, thank you, Ms. Annawat, for ya. Kemudian Pak, mungkin ini saya tanya dalam bahasa Indonesia saja, mungkin Pak bisa bantu untuk translate ke depannya.
Iya, silakan.
Berhubung topik hari ini kan berkaitan dengan bencana tsunami, terutama untuk masyarakat pesisir yang lebih difokuskan. Nah, untuk pertanyaannya di sini terkait dengan pemanfaatan ruang yang ada sekarang di Indonesia, itu kan kebanyakan didominasi memang oleh permukiman di pesisir. Nah, terkait dengan ancaman ini, kira-kira masukan dari Pak pemateri ini seperti apa untuk menjadi mungkin bahan kajian atau tinjauan atau masukan kepada pemerintah daerah di bidang pemanfaatan ruang ini. Karena kan ini kan bencana berkaitan dengan pemanfaatan ruang mungkin karena bidangnya PWK di situ, Pak. Jadi mungkin itu pertanyaannya, mungkin bisa Pak bantu translate. Terima kasih sebelumnya.
Ya, terima kasih Eri. Mr. Dr. Annawat, I think he asked about there is a issue that I considered to ask before, but I will talk in English. About in 1993, you said that in your presentation about town planning and combo structural measure. So in Ambon, we have a lot of house in coastal line. So there is it will have a bad impact when tsunami comes. So how to prevent that? So we will minimize the impact of the tsunami.
You mean for the
About town planning?
people who
About
live,
town planning.
you mean for those who live along the coast?
Yeah. Yes.
Yeah. Well, for my area it's tsunami already happened, so all the house already gone, right? So what the government wanted to do is to make sure that this thing will not happen again. So they ask people to not to live along the coast, but live somewhere far. But for Ambon, still, no very big tsunami recently, right? So
Yeah.
people already live along the coast. So I think that's different situation. So of course, it's not easy to just let people stay. Ask people to stay away from the sea and prepare new land. So that is not practical idea. So my opinion is that to make sure that they have evacuation route, because the mountain highland is just behind, right? It's very close to the sea. So of course, to save the buildings or properties may be quite difficult. Of course, you can make a photocopy of your ID or your whatever important document or some cash or whatever in the Ziploc plastic bag like that, put in your emergency bag, so that if it's a case of emergency or you have to evacuate very fast, you have a good route to the mountain, to the high ground behind. And yeah, that is, I think, the only things that quick way that you can do for a short term. For long term, I think it need planning or some money, effort, or insurance can be another point. But I think insurance in Indonesia is not so practical as well. Yeah, to spend more money for the insurance that for disaster that we don't know what will when it will happen again.
Oke, oke, thank you.
Yeah.
Jadi intinya begini, kalau misalnya kita sudah tinggal di pemukiman di pesisir pantai kan agak susah untuk pindah, untuk pemerintah untuk kayak menggusur atau kita memindahkan pemukiman tersebut. Jadi antisipasi yang pernah dilakukan oleh masyarakat di Jepang itu ya pemerintahnya menganjurkan untuk eh, bermukim di tempat yang lebih tinggi, in the higher ground ya. Jadi kita sudah tidak bisa lagi memanfaatkan pesisir pantai sebagai kawasan pemukiman. Jika kalau kita tinggalnya di kawasan yang rawan tsunami, ya otomatis secara tidak langsung pemukiman itu harus digeser ke area yang lebih tinggi. Itu yang memang dilakukan oleh masyarakat yang ada di Jepang ataupun daerah-daerah yang terdampak tsunami, yang mereka jauh lebih berpengalaman dibanding masyarakat di Ambon. Jadi memang solusi satu-satunya untuk rencana terdekat adalah mengarahkan masyarakat untuk mulai berpikir bahwa sudah tidak aman jika kita tinggal di pesisir pantai. Ya, itu yang pertama. Sedangkan untuk yang solusi jangka panjangnya ya butuh kerjasama antara masyarakat, pemerintah, investor dan lain sebagainya untuk mengantisipasi dengan berbagai macam solusi yang nantinya diterapkan oleh masyarakat tersebut. Jadi memang hal-hal seperti ini kita tidak bisa kayak ambil keputusan singkat lalu pumpang-pumpang selesai, enggak. Memang ada pendekatan-pendekatan baik secara teoritis maupun teknis di lapangan. Yang pertama ya kita harus memberikan kesadaran ke masyarakat bahwa daerah kita ini tidak terlalu aman dari sisi gempa maupun tsunami, sehingga pemukiman harus mulai diarahkan pembangunan di daerah yang jauh lebih tinggi itu. Jadi terkait town planningnya seperti itu. Mungkin bisa dipahami ya. Oke. Oke, if I think we can stop the for today because the time.
Yeah.
Or
Yes. Yeah. Thank you.
yeah. Oke. Jadi I will say thank you very much for your time
Thank you.
and about your lesson about the tsunami and mitigation. So we appreciate that. I think my student and in University Patimura University were very thankful about your information, Mr. Dr. Annawat. And
Thank you so much.
now we will have a online certificate for you. So please stay for a while.
Okay.
Fran, sudah, Fran? Okay. So this is a certificate proudly award to Dr. Annawat Suppasri as a speaker in the public lecture activity of the Urban and Regional Planning Department with the theme Japan's lesson learned on tsunami for enhancing coastal community resilience in Indonesia. Ambon, 30 September 2024. Thank you.
Thank you so much. Thank you.
Ya, ya. Oke, terima kasih guys. Semuanya selamat siang, selamat sore.
Thank you.
Ya.
Bye-bye.
Ya, thank you.
Siang. Thank you. Oke.